Have you ever listened to a voice recorded in a completely dead, silent room? It sounds perfectly clear, but it feels unnaturally close. Now imagine that same voice singing inside a massive stone cathedral. Suddenly, it has life, depth, and emotion. That sense of space is what we call reverb. Most digital tools used to create that space act a lot like flavored soft drinks. Whether it's cherry, grape, or orange, each one adds its own highly distinct taste to whatever you mix it with. In the audio world, we call that sonic character. If you are working with just one isolated voice or a lone acoustic guitar, pouring a little bit of that distinct flavor over the sound can be absolutely wonderful. It gives the instrument a rich, colorful personality. Problems emerge when we move into a modern recording environment. Today's songs often stack dozens of different instruments and vocal tracks on top of each other. If every single one of those tracks is coated in its own thick, flavored syrup, they all swirl together. The lower and middle tones of the music start to cloud over, overlapping heavily until you lose the ability to pick out who is playing what. The entire song turns into a thick, murky sludge. This creates phase smearing. The physical sound waves literally blur into one another. The crisp snap of a snare drum or the delicate breath of a vocalist, it's buried under a heavy blanket of digital echoes. So we asked ourselves a question. What if we built a digital space that didn't taste like anything at all? A tool designed strictly to add pure width and depth without leaving any sonic fingerprints behind. To keep a complex song sounding completely clear, engineers don't need another sweet, sticky soda. To hold the music properly, they need pure water. To build that perfectly clear space, we must look at how a digital echo is made. Underneath the hood, a digital reverb is built from thousands of mathematical instructions called delay lines, which constantly repeat sound waves inside an invisible room. In this simulated model, sound waves ricochet off digital walls, but timing is difficult. Thousands of waves arrive at the exact same microsecond, crashing into one another. These digital pileups create errors, sharp metallic ringing, rapid stutters, and unnatural hums. For decades, the only way to fix these pileups was manual labor. A human engineer would twist dials and adjust numbers by ear, guessing at mathematical combinations to try and untangle the overlapping waves. But a human can't track thousands of invisible paths at once. Manual tuning leaves microscopic wave collisions behind, meaning the final echo always retains a slight blur that subtly clouds the mix. To solve a problem this complex, we built a dedicated computing engine, a specialized processor designed to analyze digital spaces with absolute mathematical precision. The machine finds the perfect room through elimination, testing billions of ways to arrange echoes, searching for the one layout without any errors. The rules were incredibly strict. If two sound waves collided within a 5-second window or produced a looping hum, the computer threw it out. Out of billions of failures, the computer eventually isolated a handful of unique, highly complex layouts. These winning designs ensure the echo stays perfectly balanced. It never boosts one frequency or hides another, no matter which notes are played. By letting the machine exhaustively test every possible failure, we arrived at a pure, wide-open space, while leaving the original tone of the instrument completely untouched. This configuration splits incoming music into two independent paths. The first path shapes the immediate impact, like the quick snap of a drumstick. The second path handles the long, smooth fade. Operating separately, the lingering tail never blurs the initial strike. The system also uses a unique way of fading out. It lets the high, bright sounds disappear naturally over time, mimicking how real air absorbs sound, rather than just cutting them off or turning muddy. And because the computer verified that these waves will never collide, you can route this room through elaborate surround sound setups and multiple speakers without the signals ever interfering with each other. This mathematically precise structure creates a space that effortlessly supports a massive multi-track mix. It adds the depth the music needs while remaining completely undetectable to the ear.